Hello, ma'am. We are not able to listen you.
हेलो।
Yes, ma'am. You can. Yeah, ma'am.
हाँ
You
सर।
can start.
हाँ सर, वॉइस आ रही है सर ना, ऑडिबल है ना?
Yeah, ma'am. Yeah, ma'am.
ओके सर, ओके।
Start your presentation, ma'am, please.
ओके ओके। गुड गुड आफ्टरनून टू ऑल। थैंक you very much, Abhay sir, for providing such platform to share my work. Well, I heartily welcome to all participants. I think you will gain knowledge through this presentation. This presentation is concerned very recent topic, biocomposite materials for food packaging applications, as well as preparation characterization of biocomposite, and also study about the effect of surface modification on developed composite. So it is my pleasure to be discussing biocomposite insights with you all. First of all, we need to understand about the why advanced material is needed, why we develop the advanced material. There are uh, a lot of materials which are available, like metals, non-metals, alloys, ferrous alloys. Still, why there is requirement of such kind of materials, advanced materials, composite materials. So basically, the requirement, we should know about the requirement, and our focus is to discuss about this kind of advanced material, and also the biocomposites. So these are some contents which we'll discuss during this presentation. First, let me introduce about the materials, composite materials, then need of the biocomposites and motivation. Thereafter, I will discuss about the objective, what is the motto of sharing with these type kind of materials with you, and methodology and discussion. So first we should know about the what is the composite material. Our main attention would be to discuss the biocomposite preparation and characterization. But as one word is coming in our title is composite, so we should know about the what is composite materials. Composite materials are the multifunctional materials having two or more than two chemically distinct components. So one phase is reinforcing phase, that is discontinuous phase, and another one is matrix phase, that is continuous phase. So what are the function of these reinforcement and matrix? We should know about all these things before going through this presentation. Basic concepts should be clear. So I will explain the component of composite materials. Firstly, the reinforcement. Reinforcement may be glass, carbon, organic, boron. I think you have heard about the glass fiber, Kevlar fiber for military industry. These materials are used in aircraft industries also. So matrix material, what is the function, what is the properties of these components? It is also very important thing. So matrix may be polymer, may be metals, may be ceramic, but my work is based on the polymer based composite. So I will give the brief description about the polymer based composite. So firstly we should know about the function of the reinforcement. Reinforcement, main purpose of reinforcement is to increase the strength and stiffness of the composite. As well as we talk about the matrix main motto or main purpose of matrix is to act as a bonding element and also protect the reinforcement from external stresses, external disturbances, and main function is to transfer and distribute the load to the reinforcement. And in duration of development of these composites, some filler and additive materials are added to enhance its properties. So basic purpose of using this additive is modify the color, reduce the cost, decrease their shrinkage, and also modify their electrical and thermal properties, improve the resistance to aging, and also modify the density of materials. So composite materials are not kind of new materials. These are old materials because there are some examples like human bones and woods, which are natural occurring composite materials. And you have seen in village agricultural waste, leaves, mixed with mud for making the walls in village houses. So these materials are not, you cannot say these new materials, these are the old materials. So when we talk about the composite materials, we need to understand the definition, constituents, components, properties, engineering application, and also comparative study between the traditional and conventional materials. These are some classification of composite materials. This classification is based on the reinforcement. And why composite materials, I have already told you about the requirement of composite materials. So if we propose a new material, if we develop a new material, there should be some novel thoughts. We have proof this material should be better than existing material. So the composite material, prepared developed composite material should be some novel thoughts and also some benefits, some advantages. So maybe cost may be reduced, strength and stiffness need to be increased, fatigue life should be increased, and also the main important thing is reduce the weight of the component. Nowadays, lightweight is researchers prefer the lightweight component, lightweight material, so that fuel consumptions get reduced and expenses also reduced. So property of these composites constituents, matrix properties is different than from the reinforcement properties. We should have knowledge about this before fabrication of any kind of composites. There are types of composites based on the matrix. First one is the PMC, that is polymer matrix composite, metal matrix composite, and last one is ceramic matrix composite. And the polymer matrix composite, there are you know about the polymer is also plastic. Scientific name is polymer, but in engineering terms we say these polymer plastic. And nowadays everywhere around us we can see different kind of plastic around us, like switchboard, cameras that is recorded this presentation, there is some glass is used which is also made of non-metallic material. You can able to understand the polymer. We are not going to study about the polymer, but polymer based composite, we are also study about the polymer based composite. So basic terms and basic concepts should be clear. So that's why what is the polymer is the long chain formation of long chain of monomers polymerized to make the polymer. So I think you have studied in the chemistry in 12th class level what is the polymer, and here I am studying about the composites, matrix composite. I have clear about the I have told about the matrix and polymer. So let me introduce the basic aspects of this composite materials. These polymer matrix composite offers a good low density, high specific strength, high specific stiffness, and easy fabrication. Fabrication is easy as compared to the other type kind of composite materials and metallic materials. These are main motto is to fabricate the green composite, biocomposite. For fabrication, we need raw materials, reinforcement. So reinforcement, like natural fiber, is achieved from different kind of plants. So these are some plants, source of plants and animals fibers from which we can get the natural fibers. Natural fiber and synthetic fiber. There are two types of fibers. Uh, these are the classification of the fiber. Uh, Fibers classified into two categories. First one is natural fiber, second one is synthetic fiber. So natural fiber is classified in three categories: animal, cellulose, and mineral. But my work is based on cellulosic fibers, in which from plants. Suppose jute is we get jute from bast, thistle we get from leaves of plants. So these things which are available in evidence everywhere in all over world, these plants are available and these kind of natural fibers is used. Why we prefer these materials, I will discuss about the green, why we prefer the green composite, biocomposite. Main purpose of using this kind of material is biodegradability, because dispose these kind of material do not take too much time for disposal process. But if we use the synthetic fiber, uh, in some before some times you have, as the government has told to ban the plastic. So these are hazardous for human beings as well as animals. So synthetic fiber are not preferable over in place of natural fiber. Natural fiber are have taken the attention of researchers nowadays over the last few years, because there are some few attractive properties, favorable properties like eco-friendly, low cost, high specific properties. In the view of development of eco-friendly and environmental friendly materials for sustainable products, researchers are trying their best to minimize the use of synthetic based polymer composites. So synthetic fibers are also proven as their worth as weight saving materials and being used in automobile, military industry, aircraft industries also. But immense use of this kind of composites all over world has increased the environmental burden, because these materials are neither eco-friendly nor cost-effective and also not biodegradable. So growing ecological, social and economic awareness, high rate of depletion of petroleum resources have encouraged the search for green materials which are compatible with environment, our ecosystem. So in table you can see that the production of 1 kg of sisal fiber. Sisal fiber is natural fiber which I have used in my research work. So production of 1 kilogram of sisal, only 3.4 megajoule power is consumed. But if we talk about the synthetic fiber, the value is two more, 48.3 megajoule power consumed. Energy consumption is more in case of synthetic fiber, glass fiber. Same as we know, we our trees take the carbon dioxide gas and they leave the oxygen. So carbon dioxide gas emission is more in case of synthetic fiber during the production of this kind of fiber. If 20 kg 20 kg CO2 is emitted during the production of glass fiber. But in case of natural fiber, this value is near about 0.6 kg, is below 1 kg also. So you can get the data and you can understand very easily about the differences between what is the benefit of the using the natural fiber in place of synthetic fiber. So natural fiber, there are some advantages in natural fiber. So we why we prefer these kind of materials. These are the renewable source of raw material, cyclable in nature, recyclable in nature, high specific strength, high specific stiffness also, health and safety point of view, also less abrasive, lower cost. But there are some disadvantages also. Variation is strength, hydrophilicity, and weak interface. As I told, these plant fibers, natural fibers are obtained from plant fibers. They are hydrophilic in nature. That means they absorb the water. But if we talk about the matrix polymers, they are hydrophobic in nature. So interfacial bonding in bonding adhesion is poor in case of uh, during the production. After developing the composite, there is some issue. So there are some drawbacks. There are some drawbacks I will discuss about these. For overcoming these things, these drawbacks, I will do some surface modification also. These are the advantages of natural fibers. As we see, non-irritating nature of the natural fiber, making safer and easier to handle. But if we talk about the synthetic fiber, these are irritating in nature. For wearing, if we cloth wearing these types made of this natural synthetic fiber also health hazardous. So less energy consumption, as I told in previous slide, cost effective and also low density, availability in evidence everywhere, as all over world these fibers are available in huge amount. Advantage of natural fiber over synthetic fiber, these are the comparatively comparison between the natural fiber and synthetic fiber. Natural fiber offers a better in terms of density, cost is low, density is also low, CO2 neutral, energy consumption is also low, recyclable in nature. In these terms, natural fiber offers better properties as compared to the synthetic fiber. These are some application of natural fiber. You have seen in own house also. Doormat is made of jute and bag, rope, handbag, carpet, floor covering. All these things are made of these natural fibers. So limitations of biocomposites. There are some limitations of natural fiber uh, due to which it for structural application it is not applicable. But if we use some techniques, some modifications, some filler materials, so that these properties can improve. Hydrophilicity, as I told, hydrophilic nature of the plant fiber, that means they plant fibers or natural fibers attract the water, they absorb the water. Poor thermal stability, poor durability, poor compatibility. Compatibility with these natural fibers are not compatible with polymer. So for improving these things, some modification is needed. Inconsistency in fiber properties. Inconsistency in fiber properties that depends on harvesting time, our soil properties, rainfall conditions, and all these things depends. So uniformity is not there. Poor strength, because of this poor strength occurs, and poor interfacial bonding also. So these are remedies due to which by using some surface modifications and compatibilizer hybridization technique and use of filler material, we can overcome these drawbacks. Application of biocomposites. Before fabricating anything, before developing any kind of material or doing research, we should know about the application of particular product, where we can use this product. So first important aspect to selection of material for particular application. Suppose mouse, we are using mouse that is made of plastic. So it can be made of steel, metal, wax materials. Why we use the plastic for making the mouse? So design of material dictates which material will be suitable. So application of biocomposite are used in furniture, packaging applications, electrical electronics, automobile, building materials, sports and musical instruments. So there are some examples. Few examples are given. These materials are made up of the oil palm fiber polymer composites, which is made of the, you have seen around us. Packaging application, the sustainable packaging for cosmetic products, which is made of the Corora fiber wood floor based composites. Electrical and electronics, laptop casing, flax and kenaf polylactic acid composites are used in laptop casing for making the laptop casing. What are the benefits? What we get? Heating issue is there. So we up to which temperature we can use. So you should know all these things. Fabrication of helmet using jute polyester composites. Jute is natural fiber, polyester is thermoset plastic. So plastic is two types, thermoplast and thermoset. I have worked on the thermoset based plastic, thermoset, that is epoxy. Mobility application, helmet, for making the helmet, jute polyester composite is used. There are some automobile industries. There are some components like seat cushion, door panel, floor panel, which are made of these kind of biocomposites. Motivation: why we prefer this kind of why we work on this kind of materials nowadays. Non-degradable plastic waste and synthetic fiber cause bad impact on health as well as environment. I have told already. Main purpose, main motto of using these kind of material to because these materials are compatible with environment, our environment as well as health. In order to overcome these some drawbacks, biocomposite is widely these some problems. Biocomposite is widely used due to eco-friendly nature and biodegradability. However, biocomposites are prone to moisture. They take the moisture, yeah, they absorb the moisture. or water, inferior fire resistance, lack of fiber matrix adhesion, poor wettability, lower strength. Still, they are used. They have taken the attention of the researchers because there are some few attractive and favorable properties. So these these some drawbacks or demerits due to which limits its use in outdoor application and structural application. Therefore, to overcome these problems, surface modification of fiber is needed, which enhance the property of biocomposite. There are a lot of surface modification, which may be chemical and physical methods. Chemical treatments are there for doing these treatments. Properties get enhanced. Mainly, these natural fiber properties depend on their constituents components. Mainly, the component is cellulose, hemicellulose, lignin, pectin. So, hemicellulose, cellulose, I think you have no idea about these terms, but these are some constituents, components of natural fibers. So, cellulose, which provide the strength to the fibers. Hemicellulose is basic terms which increase the water absorption capacity. Materials and method. I have taken sisal fiber as reinforcement, epoxy resin as a polymer, and polylactic acid for coating purpose for surface modification of the on fiber. You can see the image. A is this plant of sisal fiber, and B is after synthesis, after uh, synthesis and yeah, sisal fiber, image of sisal fiber. After retting process, mechanical method apply these fiber actual this fiber is used as reinforcement, which is obtained by these plants. So there are some properties, physical and mechanical properties of the raw materials. I have purchased sisal fiber from Uttarakhand Bamboo Board, Dehradun, and epoxy from Bakshi Vedas Kanpur, and the polylactic acid is obtained from the Nature Box Chennai. Some properties. Surface modification. First technique is sodium bicarbonate. I think you have heard about the sodium bicarbonate, baking soda, which is used in food cooking during the cooking food. We use the soda, so that is also known as the sodium bicarbonate in chemistry. So this treatment is not health hazardous. So because of this nature, we prefer eco-friendly treatment. By there are some steps which will be which have I have followed for treatment. Solution of sodium bicarbonate and distilled water prepared with varying concentration. I have checked which which concentration provides the optimum result. Sisal fibers, they are soaked into solution for period 24 to 120 hours. These solution were stirred at regular interval of 1 hour during the treatment period, and fiber were removed from the solution at constant interval of time 24, 48 hours, then 72 hours, 96 hours, 120 hours. After that, these fibers were kept in hot air oven at degree Celsius at 100 degrees Celsius for 8 hours. These treated fiber again coated with using PLA, polylactic acid. PLA pellets are there, you can see, and chloroform. These pellets are immersed into chloroform. Then manual stirring is done. So in these solution, these treated fiber were immersed. Thereafter, these fibers, after coated, these fiber kept into hot air oven and dried coated tissue fiber are given in this type. So preparation of biocomposites, I have used 15 fiber length. I have chopped these fibers into 15 length, and these are designation of the composite. And the fabrication method is this composite slab is prepared by me, and sample is prepared by using this slab. Research and discussion. I have firstly I have characterized the sisal fibers, thereafter composites. So firstly, I have done the tensile test on TNS Olson machine in MIT Allahabad. Mm, we can say from the table, optimum value is obtained at 10% of NaCO3, sodium bicarbonate, and immersion time is optimum result obtained at 96 hours. So this is optimum. This concentration of NaCO3 immersion time provides the optimum results of tensile strength. Firstly, you can see after treatment, after treatment, we have done the coating on the fiber. So at 2% result, higher value of strength, higher value of tensile strength obtained at 2% of coating, and thereafter the values decrease because of the treatment. After treatment, there is some hemicellulose is removed from the surface of fiber, due to which properties get declined. Scanning electron microscopy is done in IIT Kanpur. The first, fever A shows the some impurities, some fiber cells with impurities, and after treatment we get the, after sodium bicarbonate treatment we get the fiber fibrillation take place. Fibrillation take place because of this surface gets rough. If surface is rough, that means there is more bonding take place. Good bonding, interfacial bonding with fiber and with matrix is take place, can be will be good after treatment or coating. So these EDX analysis is done also at Kanpur. If we talk about the untreated fiber, a lot of metals, chemical elements are available, but after treatment, few of them are removed because of the treatment. FTIR spectroscopy is done on MNIT Jaipur. Some it is used for finding or identify the chemical compositions and structure. So there are some possible assignments which confirms the presence of these cellulose, hemicellulose in the fiber. So this test is carried out because to verify the absence and presence of these constituents. Thermogrametric analysis (TGA) for measuring the glass transition temperature as well as the to check the thermal stability of these materials, these kind of tissue fiber before and after treatment, to check the efficiency, how efficient these materials after treatment. X-ray diffraction XRD is conducted in Unity Allahabad for measuring the crispinity index. As we see the diagram, untreated tissue fiber have lower peak as compared to the SCT1 and SCT2, that is after sodium bicarbonate treatment and also after polylactic acid coating. Water absorption behavior from diagram water. This graph is plotted between the water uptake percentage and square root of time in seconds. So first the black color shows the untreated tissue fiber which uptake the more water, but after treatment water absorption by the fiber getting declined, reduced. So the slope of the curve shows the capability of water uptake by the fibers. So highest water absorption takes place, you can say that the near about 35% by untreated sessile fibers. Before modification, before surface treatment, 34% water uptake by the untreated sessile fiber. But if we talk about the treated and coated fiber, 70 and 62% lower water uptake by the fibers after treatment. These some good things, positive results obtained after the treatment. So that if water uptake will be less, so that means the strength and interfacial bonding is also enhanced, get enhanced. Now I am going to discuss the dynamic mechanical analysis. What do you mean by the dynamic mechanical analysis? Dynamic mechanical analysis is effective tool for determining the viscoelastic properties of the crystalline polymers and composite materials. There are three terms, basic mainly terms, storage modulus, loss modulus, and tan delta. DMA is also used for measuring the glass transition temperature. So glass transition temperature, what is the glass transition temperature? If we use these developed composite materials in packaging application, suppose we are using these materials in packaging, food packaging. So there are various issues like temperature differences. Temperature variations in all over India is not constant. In some places there is not too much cold, and there is some in some places always warm. So if we use in packing application, so we should know about the glass transition temperature of particular product. So glass transition temperature is the temperature range where thermosetting polymer changes their state from glassy state to rubbery state. You uh, it is different from the melting point temperature, quite different from the melting temperature. In melting point, the material begins to melt, but in case of glass transition temperature, material gets softer, not melting starts. So storage modulus, you can say storage modulus graph. In this graph there is three reasons. First one is glassy state, second one is transition state, and third one is last one is this one is glassy state, this one is transition state. There is huge loss in stiffness. Because of loss in stiffness, as we increase the temperature, storage the value of storage modulus decline. Because if you increase the temperature, storage modulus capacity reduces for the composite. So this one is transition region, mid one is transition region, and last one is rubbery state, rubbery region. So storage modulus dictates about the stiffness of the material, how stiff the material. And we can see the blue curve is shown after the treatment SCT2. This curve, this composite present good, offers a good storage modulus as compared to another two one. So coating of the fiber is very useful to improve the stiffness as well as storage storage capability. As a result increase in storage modulus. Second important parameter is loss modulus, which dictates the viscous response of material. We can understand by giving an example. If when a ball is allowed to bounce, it results some energy to be dissipated and some energy saved for future. Means if ball is bounced freely, so this ball will not attain their original position. Here some energy will be dissipated and some energy will save for future. So which energy is dissipated, that is loss modulus, and the save for future, that is storage modulus. So we can get the value of glass transition temperature from the loss modulus curve. This curve is also plot between the variation in loss modulus with respect to temperature. Temperature is near about 70 degrees Celsius. At 70 degrees Celsius, we get our glass transition temperature value near about 79 degrees Celsius for SCT2. We can get all these data we can see all data in this table. So glass transition value is more in case of SCT2, and untreated one near about 56 degrees Celsius, and our room temperature near about 25-28 degrees Celsius. In summer, the weather environment temperature is 45 degrees Celsius near about. So TG, glass transition temperature, means up to this temperature, this material can sustain. After going above this temperature, material get change their own state from glassy state to rubbery state, become softer. So this not applicable above the 56 degrees Celsius. In case of SCT2, we can use up to 78 degrees Celsius. Damping factor, tan delta damping factor, which represents defined as a ratio of loss modulus and storage modulus. So these are three parameters. There are three parameters which are temperature dependent and provide the information about the interfacial bonding between the fiber and matrix. So basically, DME, dynamic mechanical analysis, also predicts the effect of time and temperature on polymer viscoelastic properties under the different environments. These are some conclusions. So the after treatment, after coating, after modification, what results obtained and enhancement properties take place. Thank you.
Thank you, ma'am, for your nice presentation. If anyone have question to ma'am, please raise your hand. If there is any question, please raise your hand or write in the chat box. Dear participants, if you have any question or any query, please raise your hand or write the question in the chat box. Yes, Dharmjeet De Brahma. If you have any question, please ask. Please ask Devjit. Write your question.
Hello, हाँ,
Ma'am,
Dhanjeet.
yeah,
Yeah,
ma'am, you can see the
every
question.
fiber has some advantages. Hello.
Yes, sir. Yes, ma'am, you can.
Every fiber, bamboo fiber, it may be bamboo, it may be any kind of bast fiber, any kind of leaf fiber. There are few advantages as well as some disadvantages. Suppose water uptake properties, pectin values, if hemicellulose content, hemicellulose cellulose content. So I have told which for which application you are focusing. Application is main motto, means what you want, impact strength should be more or tensile strength should be more, thermal stability point of view से अब means आप किस application को देखते हुए आप क्या चाहते हो. So important aspect is application, selection of materials for particular application. Bamboo fiber is good. You can get bamboo fiber and their properties, physical and mechanical properties, their constituent compositions. Then thereafter, you get a lot of literature reviews and use as reinforcement for preparing your composite.
If any more questions, if you have, you can ask to the ma'am. Dear participants, if you have any question, you can ask to the ma'am. You can unmute yourself and ask the question to ma'am. Hello participants. No questions yet. I think there is no question from anybody. If you have any questions or if you have any doubt, you can write in the chat box also. If you are not able to open your mic. Thank you, ma'am. Thank you, ma'am. On the behalf of Government Polytechnic Tekari, we are blessed with your lecture that you have given to us. We are hoping for new concern that we can do many webinars in the future also. It is a very immense, it's a pleasure for us that you have given a nice presentation to our participants. Thank you very much, ma'am. On the behalf of Government Polytechnic Tekari, I am thanking you. And thank you all for being here today and taking the time to patiently listen to what ma'am has said. I wish you all a very good day. Thank you very much, participants. Ma'am, you can, thank you very much, ma'am. He can, yes, ma'am. Participant, there is, I have shared a link in the chat box. Please fill it. Fill it. It is attendance, and this is necessary for the generation of your certificates. So please fill this form. As you fill this form, we should send a link to your registered mail, and there should be a certificate for you in the in your mail. Please do fill the attendance as soon as possible. As I got only 48 attendance, that there is 76 participants, but we are getting only 48 attendance. Please do fast, as we are ready to end at the meeting. Please fill the attendance.